Okay, so video number 4 today. Let's hope we can get through it. Moonraker Master from a customer. We also have a Moonraker Master, and ours is a bit dusty, but it's fully serviced. But I can use that for reference. That feels heavy enough to have got batteries in. Only a fool would leave batteries in. Good. Doesn't make me a fool then. This we bought with a broken aerial, and it was at a time when Knights at Curtin and Lindsay still had the aerials for £9.99, and that's the last time we were able to buy a aerial, and I wouldn't have bought this had they not had those at that time. So I think we had the last aerial off them. So put that on one side. We can get that out for reference if we need to be, because I've no doubt we've got no service information. So we're doing the 410T, the Harvard 410T. These come out of the same factory, and a few years later on. They're still quite a fragile radio, but they could be said to be better radios. They have a more conventional output device, and he says he's had the smoke, and that was a quick sniff of the smoke then. So I'm just going to check that his adapter, I'm glad he sent that, is doing 12 volts positive centre. And these are a 12 volt radio, they're not a 13.8 volt radio. 13.8 volts could kill them. At least they've got a earphone socket on this, so we don't have to take the board out to hook it up to the test instruments to do Synad. So that's a real step forwards. Let's have a look what we've got. Well, on that power supply at the moment we're doing 14.2 volts, but the point is it is centre positive, and that's what we're here to check. So that's done that. I'll connect it to the other power supply anyway, because this is the 18 amp power supply which we use for commercial business radios, and I need to use a 2.5 amp power supply which we have current limited, and I'll just make sure that that's set quite low. In fact, I'm going to short out the output. I'm going to turn that off as well, and let's see what the output is. Right, I've set it to 0.5 amp. So he couldn't get it to come on. It's a bit flimsy, isn't it? Anyway, we'll connect our crocodile clip leads to that. No power. No power. Okay. At least it doesn't smell of being burnt. Oh, his serial number is 43341. Ours is 55411. So ours is actually slightly newer. Oh, these are a faff to open up. I'm glad I've played the church organ for today, because if I break my fingernails off. There we are. So after pushing it down, withdrawing it, hoping his aerial's intact. The fact you've got that screening on the back. Oh, well, you know, straight away we've got no aerial connected, have we? So, yeah, that's brilliant. What on earth's going on in here? Oh yeah, so the antenna loading coil is there and the output goes to there, so it's come unsoldered, so we can deal with that right at the end. I think under the circumstances, I mean, I won't do it this second, but we'll unsolder the battery leads. It'll make it easier. Now, how's this held together? This is where I take out all the wrong screws. That's one of them. So you don't take all the screws out to get it out of the case. Perhaps it's that one. No, that's a machine screw, so I'll put that straight back. I'll just take these knobs off as well. So we didn't need to take anything further out. So it's much better quality than the Harvard 410 in the way it's built. So I think what we're going to have to do is to take the screen plate off, because if he's had some magic smoke, we really do need to see, for example, underneath the power input socket. That could be our first port of call for a problem. And I can already see some moisture ingress, which isn't going to help. So we'll start by unsoldering that. Use a solder sucker later to do it properly. The ingress of moisture is in fact only at that corner, but I will deal with that because otherwise it could end up with problems later down the line. So can we see anything round this power input socket? And the answer is no, we can't. Looks fine. So I'll tell you what we'll do. We'll power it up from the battery connector. I'll just drop that power supply to 12 volts. We'll just do it from here initially. No idea which button does what. Anyway, so we've still got nothing. So I'll connect the prod to the negative prod to power. We'll just check we've got power showing. We have. Then we'll go to the on-off switch. Got nothing that side. and we've got nothing that side. So that doesn't sound very promising. We've got no overload. So we'll just turn the power supply off. We'll check for continuity between power ground, which I've got there, and chassis. We have that. So it's the positive lead that's open circuit somewhere down the line. So between there and the on and off switch, nothing on either. So see if we can find where it's disappeared off to. To be honest, you'd expect it to be a duff switch within that. So we'll power it back up again. We've got 12 volts there. We have a switch to, that's negative, that's negative. So it's not the switch that's faulty. So they're switching the negative in this case. So we've got it to the protection diode. Right next to the socket there. Okay, so we see where the magic smokes come from. The power disappears onto this subboard to the on-off switch and back through that connector. So looking down there, and what we have is burnt out track. So that's where the magic smokes come from. So if we can zoom in on that. We're looking at that track there. So I need to put a wire link between there and there. That's all we can really do. And you know what I reckon's happened? Because it's a very thin track there. I reckon that it was poor performance because that wire'd come off. And then when he went to use it another time, all the transmit power, and it's 4-watt radio, that has to be high. It'll draw massive current, and that's kind of acted like a fuse. So if I look at a photocopy of his letter, the radio current doesn't even switch on. Puff of magic smoke last time. Previous to that, no transmit and receive, and it would get better. It would benefit from a tune-up. I think that's what the course of events is. So I think probably best cutting out that bit because it could flap around in the breeze and short something else out. Okay, so now chances are it'll power up. Hey! Good. So we'll do. May as well do the tune-up with it all in bits, but I will just screw this board with its 5 screws back into its pillars. I say that carefully. The frequency adjust is under there. No, we're going to have to do the frequency first. So we'll go into the external antenna socket there. And we know we've got one of those adapters because I was waving it at the camera the other day. That's the RCA adapter. I don't have a particular sequence, but I don't like boards flapping around like this, so I think the thing to do is, the very first thing to do is we'll get the frequency adjusted, make sure it's spot on. You've got that under there. What else have you got? That's a VCO, that'll be alright. I mean, apart from that, the radio isn't going to be faulty, so we'll just do a bit of a tune-up and Bob's your uncle. So power it back up. And now go into picture-in-picture. We're on channel 20 because we saw that. Press transmit. Oh no, we've got absolutely nothing coming out of it. So are we in low power or something? I don't know. Or has it ruined the transmitter? RF power is the centre one. So at the moment we're drawing 90 milliamps. We'll take the display off, we're drawing 70 milliamps, 50 milliamps. We'll just see whether it's receiving at all. And the answer is no, it's not. So we've got no transmit, no receive, so the synthesizer's not operating, is it? Oh dear. I'm just wondering if there's a voltage regulator somewhere. See if we've got a circuit diagram. I really don't think I have. This could be one of those send it back and can't economically fix it. So I threatened it with the circuit diagram. I just was going to say this goes to the synthesizer. We've got a 6.2 volt Zener. We've got a 22 ohm resistor. There's transistor 9. So I was just going to threaten it with that. And that is the resistor, the transistor there, and it burst into life as I pulled on these wires. So I've been on these with a fiberglass brush, and it's now receiving, as you can see, and it is now transmitting. I think that's low power. Yeah. So straight away, what's it doing? I'll go into our... Oh, it's 3.5 watts. Yeah. So that's great. Now what we will do, I'll just put this on to number 2. And we can just trim the frequency. So I'll press transmit. We've got 27,79118. Oh, that's neither here nor there. But we'll pull it up while it's in bits. And it must be 27,79125. Oh, that's interesting. It's going down now. It's one of the better type of trimmers, this. Actually got some silver in it. Whoa, that's spot on. We'll leave it there. Well, that's most satisfactory. Just check that they are the early stages of the transmit. They are. That's peak. Because that will get put back together next. There's no presets under there. So what's under that board is now done with. So I'll be pleased when I can put that board back together, because it's difficult juggling things like this. Oh, he's very lucky there. So look, we've got a bar graph out. So it's been pushed in, it's out of line with the others, and however it's got pushed in has broken it. So we'll see if we can remove that, and I reckon we'll have got a scrap fake Amstrad somewhere. We'll pinch one of those LEDs. We don't have these in stock. It really doesn't matter, but it'll be nice for him, and I'll charge him a token penny. I'll get rich on that. So in fact, I didn't have to change the LED. When I looked at it, and I'll show you what I've done to bodge it, I unsoldered the right hand leg, and it was dry joint. Let's just zoom in on this. So the right hand leg was dry joint and pushed through, and the left hand leg, the print had snapped away as it's been pushed in, and so there was no print pad. And this is the common, which goes to all of them. So I've put a white wire from there to there. That's today's second wire link bodge on the same radio. Right, we'll get those. I keep saying this. We'll get these little screws in, so this display board isn't flapping around all vulnerable. Of course, I've disturbed the way the wires are dressed, and that doesn't help. What you've got to make sure now is that you're not trapping wires underneath and onto the pillars. So we'll get those in. Well, I shouldn't have taken those two out. They do the control panel. I don't think we've done one of these on video as a tune-up before. I'm not going to look at the back catalogue. Okay, that should be somewhat less vulnerable now. Switch it on. Hey! Wonder when that last worked. Didn't tell me that in his letter. Right, we've moved on to alignment. I've made myself some kind of notes from the circuit diagram. I didn't realise we had that, so I'm pleased about having the circuit diagram. I think we can put this meter away. We've done the 2 down there, which I suspect are 5 and 6, and we now need to see if we can see what numbers are on these. So T2 is receive, T3 is receive, T4 is receive, I'm just going to give that a twiddle. Yeah, that's definitely affecting receive. So that must be T1. So T1, T2, T3, T4, which is the detector. So the only coil we've got left with, and I mean there's nothing wrong with the power anyway, it's doing a plumbing sight more than a lot of new sets do, new mobiles. Just this one to look at, so I'll put the soldering on so we can melt the wax. It's an RF power meter. It really is an RF power meter. So it's not just a battery meter like in the Harvard 410. Found another one of those on my shelf without the battery door. Are we in low power again? We are. By the time I've faffed about, yes, it's about 3.5 watts. So there's no improvement whatsoever to its transmit. And just for the laugh, we'll see what Zetagi watts it is. So this is at least 10% fast. 4 watts on the dot. Good. So what we would like to do, I think, is to set the RF meter, which is VR3. So that's VR2, which is Squelch. There's vertical one there, not labelled. I can't actually see 4. Oh. RV4 deviation is on its side down there. So we'll do that. We'll do that now. So we'll put our oscillator under the microphone, if I can find the microphone. Oh, the microphone's there, is it? we'll set that to 2, and then give it the... You know, I've just had to retune the meter, and it's because it's gone on to channel 9. And that's because I've pressed one of those push buttons. Anyway, we'll carry on. Oh, Wallow, testing 1, 2. Wallow. Well, that seems right. We'll go back to channel 20 and listen on our Moonraker, not Moonraker, Allen 42 thingy. Testing 1, 2, testing 1, 2, 1, 2, 1, 2. Well, that seems to be right. So RF meter, S meter and Squelch. So the only one we've been able to... Oh, we know that was RV4. We know that's RV2. I think that's RV1, which means the one on its side there is RV3, which will be the RF meter. It is. So we'll just have it to the 4th light, just lights. And then hopefully when we go to low power, whichever that is, 1 will light. That's correct. Now low power isn't adjustable, and it's doing 500 and a bit milliwatts. So I think we've covered transmit, and we'll just nip on to the receive. So we need to connect this to the test equipment, and on this model we can do. I was going to say we don't have to bother taking the board out of the... Yeah, right, but we did do all those repairs, didn't we? So we're now plugged into the test equipment, and we'll start with that. And that's the detector we will need to be adjusting. That's T4. Oh, look at that, we got some more out of that. So at the moment, I should have done this a bit earlier, we're doing 2.4 microvolts for 12 decibel cyanide, which doesn't sound fantastic, but it's about where the other ones were. So we'll lower these, we'll lower the signal and see whether we can improve that. So T1, which I've messed with before, is that one we determined. So that's definitely peak. T2. I'll just check with that one a second time. Attenuate the signal further. And then we'll just do this as probably an IF one. Whoa! So now we'll just check these are right again. Yeah, I think we've cracked it there. So what we got now, 1.3 microvolts for 12 decibels. So yeah, huge improvement. Of course, I'm not showing the meter, am I? So there's our 12 decibel setting. Might help if it's back in the case as well. So we've got 1.3 for 10 decibels and 1.8 for 20 decibels. So we now want to put S9 on the radio and adjust the meter to read what? It's calibrated 15930, so it should be lighting the third one. And it's RV2, and RV2 is there. No, that's Squelch. RV3 is that one. There we go. So if I turn the signal down, that's a bit two at once. No, it isn't two at once, but they're very close together. And then 100 microvolts, 300 microvolts. Now I need that fourth one to light. So we're going to have to play. We're going to have to have it so it's just lights. That's it. 300 microvolts, 100 microvolts, 30 microvolts, 10 microvolts, 3 microvolts. Yep, that's it. Now we'll do the Squelch. So with we'll put this on the attenuator control of the signal generator, and we'll set the Squelch for 0. And I've got the Squelch so harsh that it's on all the time. So we're going to set the Squelch to full, turn the signal generator up, 1 microvolt, 3 microvolts, 10 microvolts. I want the Squelch harsher than that. 30 microvolts, 100 microvolts. I want the Squelch to come in at that. That's exactly where I want it. So full Squelch is 100 microvolts, which is S9. So minimum Squelch. Turn the signal generator off. Set Squelch to threshold. Signal generator on, it sparks at 0.3 microvolts. 1 microvolt, it's coming in. 0.9, it's leaving. So we've cracked it. That Squelch is fine. So that's it, we're done. Now all we've got to do is to put that shield plate back on, put the radio together and solder the original problem, which is the output lead to the antenna. Placement of this is going to have to be absolutely spot on. And I didn't take the old solder off because at least I can see where it goes. I've never cleaned that corrosion, so I'll just do that before I'll turn the power supply off. Otherwise I could end up not being able to get to it. I know it's only the corner, but I did spot it and it would be prudent to do it. That's the isopropyl alcohol. Alright, we'll carry on putting this together. This is traditional 60/40 solder. None of your lead-free stuff, because we're in the business of doing repairs to vintage equipment. We're allowed to buy this. One, two, three, four. Was there another one? No, I think that's it. Good. So we can put this back in its case. Right, so I have soldered the aerial connector to the loading coil. I won't be checking the loading coil because it's plastic welded into position and it won't have been faffed with, so it will be correct. So it's quite a thing. I've had to prop it up on the lid and then put it sideways because the lead, of course, isn't that long. So now I've got to make sure that wire is dressed in such a way nothing touches, and then hopefully it'll all clip together, he says. I think that's all clipped together. It has the one screw, and I hope I've done this in the right sequence, and then we put the lid on. You know, those don't poke out, so how could that one get bent? You know, you can see the LEDs down there. How can they get bent? Yep, that's all clipped together. So we should have three knobs, and they want to be in the correct position. So we'll turn those to off. So there. There. Probably there for channel 20. And there we have it. And as a courtesy, I'll just run over these contacts with our fiberglass brush. I'm sure the customer knows it'll be 8 rechargeable batteries. Sorry, start that again. It'll be 10 rechargeable batteries, or 8 AA alkalines. So whichever way you do it, you get 12 volts and not more. Because if you inadvertently put 10 AA alkalines, you'd end up with 15 volts and would destroy the output transistor at least. No nasty battery juice. It's in lovely condition, certainly in better condition than mine. Dust aside, you know, mine's had some wear. In fact, it worked so well, we were using it as the talkback radio when we were doing some range tests some years ago. can now power it off the customer's cigarette lighter lead. And we'll do that to the crocodile clips because I don't want to power it from the big power supply. That doesn't have current limiting. Well, it does at 18 amps, but you'd have burnt the thing to cinder by then. Okay, so that's not giving us anything, and that's not giving us anything. See if there's something amiss inside here. It's no grip in there, it's like the fuse is missing. So on this type, both the left and the right springy negatives are connected, because you know on some of these only one side is connected. That's why I just tried both. So is the fuse missing? Nope, and it works. Oh, I think there's some spring tension needs improving, because it's so. You know what? This is the wrong way round. Surely. All right, we'll just pull that out a bit. I'd have thought the spring was going to be down there, but oh well. It may be just that spring's got compressed. So you're not going to have any contact until that pushes in. Okay. So final testing to the instruments. S9, S9, check transmit. Just put the camera back on that. Wallow, 3 watts plus. And we're at 12 volts. I'm not going to mess about with the voltage on the power supply because it's customer set and I could easily destroy it. So his radio is doing it's about 3 watts as we're doing it at the moment. Alright, we'll put the customer set on the aerial. Ready for a scratchy corner test with Mr. Chippy. I think we've got a Cybernet ZX1 emergency kit tomorrow. You'll be fed up of emergency kits because we've got another Midland emergency kit to do this week as well. I'm looking for the mic, and because it's built in. Well, no, Roger. Okay, there we have it. God, I can't listen to that. There you have it, the customer's Moonraker Master. I think they're about 1987. And it works very nicely, and it's a credit to its years of ownership of whoever's owned it, and its box as well. Thank you for watching.